In this recording in our series of pocket operations, we'll be going into open pockets and seeing how we actually handle open pockets. If we take a look at this part, this surface has open edges to it. We have walls, we also have open edges. So this is what we call an open pocket. If we also take a look at the updated stock up until this point, and I'll go to the last operation, all the material up until this edge had been removed, and therefore we can approach it also from the outside over here. So let's take a look how it actually works. We'll start a pocket operation, and in the geometry I will choose just this face over here. And what you'll note is that it's automatically marked as closed edges over here around the wall, but note where it is open, the edges are open, it is clearly marked as an open edge. We'll just accept that and take a look what happens on those open edges in our preview. You'll note that they move away from the edge. In other words, what happens is in our open edges, we have an automatic offset of 2 millimeters away from the wall, just to make sure we have extra clearance over there. Of course, you can manipulate this to whatever value you want. Okay, I'll choose a tool, and I'm just going to choose what I have available. I'm just going to use the 6 millimeter end mill. The levels are automatically recognized, and let's go to our technology. In a technology, we have the option of open pocket. In open pocket, by default, we're using a profile strategy. That basically means it's taking a look, and the tool path will be according to the profile of that particular edge. So we'll have more like a racetrack sort of tool path. Now also note that this area here, even though it's marked as an open edge, there's still full material on top of it, so it will just clear it as one whole area because it recognizes material that has to be removed over there. Now in our links, helical in this particular case will not have any effect. What we do need is a lead in and a lead out. So I'm just going to use an arc lead in, and I'll do the same for the lead out, and I'll do save and calculate. Now if we take a look at the toolpath before I actually run simulation, we'll note the following. We'll see the actual toolpath that's going on over here, and you can see that it looks almost like a racetrack. Now take a look also at the lead in and lead out of arc. I don't necessarily like the way this is going in. I don't necessarily like it coming down here and then going back over here. I'd like to actually start over here and work its way in. So the way I can change that is simple. In my links, I'm using the arc, but right now it's going from the center of the arc. That's where it's starting its toolpath. I just want it at a distance, and I'm going to keep that distance at 0. Look what happens now when I do save and calculate. I'll do save and calculate, and you can see now that the toolpath will start from that point over here. Let's see this now actually in our simulation, and we'll run our first step, and you can see that the tool now will go down, do that arc movement, and you can see that over there, and let me just zoom out, and then we'll run our simulation. Let's do it a little bit slower as it goes down to each level, and you can see it's almost like a racetrack type of toolpath, finishing off that entire pocket. Now it could be noted that also this area over here is also considered an open pocket. If we close our simulation, you can see this is an open pocket from over here, and even this area had been machined out in the middle over here. I can add that if I want to my current geometry. I'll just do edit geometry, and I'll just click on this face over here, and note it'll automatically give me those boundaries. Click on that. Let's go to my levels, and you'll note that it automatically goes to variable levels as well, because these are two separate levels. Save and calculate, simulate, and run my simulation, as you can see, it machines out both that area and this area as an open pocket.